provide information about the slope of the function at any given point. So next, technique of differentiation. So first, we have power rule. It is used to differentiate power of x. So second, we have quotient rule. It is applied when one function is divided by another. So third, we have constant rule. It is used when the derivative of constant is 0. So fourth, we have chain rule. It is used when a function is inside another function. So fifth, we have product rule. It is applied when two functions are multiplied. So sixth, we have trigonometric rule. It is used for differentiating sine, cosine, tangent and other trigonometric functions. So 7, we have exponential rule. It is used for differentiating exponential function. So 8, we have generalized power rule. It is used for extension of the power rule when the base is function. And lastly, we have logarithm rule. It is used for differentiating logarithm function.
For question 2, we need to differentiate the function respect to x, which is fx equal to e to x ln sin 3x. The problem statement in this question is we need to differentiate a complex mathematical function which is fx equal to e power of 2x ln sin 3x. The objective in this question is we need to find the derivative of fx equal to e power of 2x ln sin 3x accurately by using the correct differentiation rules. For this question, we need to solve it by using product rule. The methodology is to identify the type of function. The function is a product of two functions, which is u equal to e power of 2x, v equal to ln sin 3x. Secondly, we should apply a product rule. The product rule formula is f prime x equal to uv prime plus vu prime. Thirdly, we need to differentiate each function. The first function is defined as u equal to e power of 2x. To differentiate this function, the exponential differentiation rule is applied together with the chain rule. Since the exponent is 2x, the derivative is 2. Therefore, the derivative of e power of 2x is obtained by multiplying e power of 2x by 2. Hence, u prime equal to 2e power of 2x. The second function is defined as v equal to ln sin 3x. To differentiate this function, the logarithmic differentiation rule is applied. The derivative of ln x is 1 over x, so the derivative of ln sin 3x become 1 over sin 3x multiplied by the derivative of sin 3x. Next, the chain rule is applied to sin 3x. Since the derivative of sin 3x is 3 cos 3x, the result is 3 cos 3x over sin 3x. Last but not least, when we substitute into the formula f prime x equal to uv prime plus vu prime, we got f prime x equal to e power of 2x 3 cos 3x over sin 3x plus ln sin 3x 2e power of 2x. Lastly, we need to simplify the final answer, which is f prime x equal to e power of 2x 3 cos 3x over sin 3x plus 2 ln sin 3x. This is the final answer for question number 2. So, let me show you how to solve this question. So, the first step, we should identify the type of product, which is u equal to e power of 2x, v equal to ln sin 3x. Secondly, we should differentiate u. Therefore, we got u prime equal to 2e power of 2x. Next, we should differentiate v equal to ln sin 3x using the chain rule. The derivative of ln x is 1 over x. So, v prime equal to 1 over sin 3x bracket 3 cos 3x. Next, we should simplify 1 over sin 3x bracket 3 cos 3x to 3 cos 3x over sin 3x. Now, we should substitute u prime, v and v prime into the product rule formula, which is f prime x equal to uv prime plus vu prime. When we sub into the formula, we got f prime x equal to e power of 2x bracket 3 cos 3x over sin 3x plus ln sin 3x bracket 2e power of 2x. When we differentiate f prime x equal to e power of 2x bracket 3 cos 3x over sin 3x plus ln sin 3x bracket 2e power of 2x. When we differentiate it, we got f prime x equal to 3e power of 2x cos 3x over sin 3x plus 2e power of 2x ln sin 3x. Lastly, we should factor out the common factor e power of 2x from both terms, which is when e power of 2x is factored out from the first term, the remaining part is 3 cos 3x over sin 3x. When e power of 2x is factored out from the second terms, the remaining part is 2 ln sin 3x. So, the final answer is e power of 2x bracket 3 cos 3x over sin 3x plus 2 ln sin 3x. So, that's all for question 2. For question 3, I will pass to Hanim.
Question number 3. Problem statement for question number 3 is given 2x squared y plus sin xy plus x ln y equal to 5. Find dy dx using implicit differentiation. Type of question. This is an implicit differentiation problem because the variable y is not expressed implicitly as function of x. Both x and y appear together in the same equation, so differentiation must be performed by implicitly with respect to x. The objective is to determine the derivative dy dx, which represent the rate of change of y respect to x. The right method to solve this question is implicit differentiation. The applying product rule, chain rule, differentiation of logarithmic function, and collection of all dy dx term and solving for dy dx. Next, I'm gonna explain the problem solution for question 3. First step, we need to differentiate each term with respect to x using product rule and chain rule. First term, for the first term, 2x squared y, we need to differentiate using product rule, which is uv prime plus vu prime. And for the last result, we got 2x squared dy dx plus 4xy. For the second term, sin xy, we need to differentiate using product rule and chain rule. And for the last result, we got x cos xy dy dx plus y cos xy. And for the third term, x ln y, we need to differentiate this term using product rule. And we got x per y dy dx plus ln y. And for the last term, 5, we need to differentiate to become 0. And step 2, we need to combine all the differentiate term in one equation, which is it become 2x squared dy dx plus 4xy plus x cos xy dy dx plus y cos xy plus x per y dy dx plus ln y equal to 0. And step 3, we need to group and isolate dy dx. We need to move term with dy dx to left hand side and move term without dy dx to right hand side. And then for the left hand side, we need to isolate dy dx. Then from the left hand side, we need to move the bracket without dy dx and divide with right hand side, which is it become dy dx equal to negative 4xy minus y cos xy minus ln y. Divide 2x square plus x cos xy plus x per y. And that's for the final answer.
Question 4. Use linear approximation to estimate the value of set 3 63.9 minus 1 over set 63.9. Correct the 3 decimal places. So, there is 5 ways to solve this question. Step 1. Identify fx and f prime x. Let x equals to 63.9. Fx equals to x to the power of 1 over 3 minus 1 over x to the power of 1 over 2. For f prime x, we differentiate the fx and we will get 1 over 3x to the power of 1 over 3 minus 1 plus 1 over 2x to the power of negative 1 over 2 minus 1. And we will get 1 over 3x to the power of 2 over 3 plus 1 over 2x to the power of 3 over 2. Step 2. Given value x is 63.9. The chosen value is x naught equals to 64 because it's the closest number to 63.9. And dx equals to x minus x naught, which is 63.9 minus 64, and we will get negative 0.1. Step 3. Evaluate fx naught and f prime x naught. For fx naught equals to 64 to the power of 1 over 3 minus 64 to the power of negative 1 over 2 equals to 4 minus 1 over 8 equals 31 over 8. For f prime x naught is 1 over 3 times 64 to the power of 2 over 3 plus 1 over 2 times 64 to the power of 3 over 2. And we will get 1 over 48 plus 1 over 1024. And we will get 67 over 3072. Step 4. Find differentiate df. So, df equals to f prime x naught times dx. So, 67 over 3072 times negative 0.1, and we will get negative 0.00218. And step 5, fx equals to fx naught plus f prime x naught times dx. So, 31 over 8 plus 67 over 3072 times negative 0.1, and we will get 3.873 in 3 decimal places. So in conclusion, the technique of differentiation in calculus provides systematic ways to find derivative of many types of functions. By applying rules such as the power rule, product rule, quotient rule, and change rule, problems become easier to solve and understand. These techniques are not only important for calculus itself, but also for real-life application in science, engineering, and economy. Mastering them build a strong foundation for future study and help students develop logical and analytical thinking skills. So, for the next question is...
Hey, Shao! It's already done! Okay, bye!